Hello, I'm David Jackson, and thank you for watching our video series entitled Reconnecting the Dots for Profit. How do you know when something works really well? The answer is when its performance can be validated in many different ways. CO2 technology performance can be validated in several ways. For example, product cleanliness, particles, residues, product performance, bond strength, surface roughness, process performance, adaptability to process, productivity enhancements, specialized metrology, material compatibility, sterility, just to name a few. These performance metrics represent conventional wisdom. A more unconventional CO2 performance metric is business economic performance in terms of cash recovery, cash flow, cash velocity, and cash weight state. CPU-powered manufacturing processes generate cash flow by reducing or eliminating manufacturing wastes. Welcome to our first video in this series entitled CO2 Tech Leverages Waste, which is Cash. The value of a CPU-powered manufacturing process as compared to a conventional manufacturing process can be measured as a reduction in processing cost. For example, a reduction in cost per part, CPP, cleaned, cooled, or lubricated using a CPU. A lower CPP drives both the balance sheet and the P&L, for example, inventory and cost per part processed. The difference between the conventional CPP and CPU-powered CPP is equivalent to the recovered cash flow in a manufacturing process. A manufacturing waste wheel graphically depicts cash waste generated before, during, and after a production process. For example, during abrasive grinding, coolants, cutting tools, time, labor, odors, and aerosols, waste coolants, sludge, cleaning, and wastewater are all forms of input and output wastes. Eight common forms of waste are represented as radial spokes on the wheel. Manufacturing wastes are directly or indirectly related and codependent, with one type of waste impacting one or more other wastes, positively or negatively. The manufacturing waste wheel represents the cash flow performance, including both cash inflows and cash outflows, of a particular value-added or non-value-added manufacturing process. Value-added manufacturing processes transform a product through the manufacturing cycle. Examples include machining, welding, bonding, assembly, and coating, among others. Non-value-added manufacturing processes do not transform the product being manufactured. Examples include cleaning, cooling, lubrication, and inspection, among many others. CO2 technology directly or indirectly leverages both the inputs and outputs of value-added and non-value-added manufacturing processes to reduce manufacturing waste. Process inputs such as labor, materials, energy, equipment, tools, space, and time, and process outputs such as the 8 wastes: overproduction, motion, defects, transport, environmental, inventory, weighting, and processing, all are directly or indirectly leveraged. Reducing these wastes generates cash. The perimeter of the manufacturing waste wheel represents the maximum cash waste state permissible in a manufacturing process. Above this point, it is impossible to operate profitably. The total cash waste generated is the area bounded by all manufacturing wastes, process inputs, and 8 common waste outputs within the gray space. The hub of the manufacturing waste wheel represents the minimal cash waste state. The minimal cash waste state represents the absolute smallest amount of cash wasted while processing a product and is limited only by human and technological constraints. The primary objective in a CO2-enabled manufacturing process transformation is to reduce cash waste generation, moving toward the minimal cash waste state. Manufacturing processes such as aqueous cleaning and CO2 cleaning have markedly different impacts on manufacturing wastes and waste generation rates, for example, over-processing waste. This difference represents the cash recovery potential. The level of cash waste generation for a conventional process is represented as an average cash waste generation rate. This comprises the sum of the cash wastes generated divided by process cycle time. This is depicted as a blue dashed circle. Usually unknown or unaccounted for are the actual individual cash flows attributed to each form of manufacturing waste, represented by the blue dots and connecting lines. Decreasing manufacturing process waste generation decreases production takt time, which increases cash flow and cash velocity for your business. CPU-powered technology decreases manufacturing waste generation in one or more dimensions. For example, product defects. CPU are used in this process, or CO2 processing units. CO2 processing units comprise CO2 composite spray systems for cleaning and cooling, lubrication, centrifugal CO2 systems for immersion cleaning and extraction, and particle plasma systems for hybrid surface treatments. The blue dot represents 0% reduction, that is before the application of CO2 processing technology. The green dot represents 100% of the defect reduction possible employing CO2 processing technology. The difference between the CPU-powered process and conventional process represents 100% of the cash recovery opportunity, both increased cash flow and cash velocity. The new CPU-powered process provides a lower average waste generation rate, depicted as the green dashed circle, which represents the individual and interconnected manufacturing wastes. Measurable direct impacts to motion, defects, transport, environmental, weighting, and processing wastes are readily determined by comparison to the conventional manufacturing process being replaced or modified by CO2 technology. Reductions in overproduction and inventory wastes are estimated as indirect impacts related to the other manufacturing waste reductions. CO2 technology increases cash flow for a business. It does this by reducing manufacturing process input wastes and reduces manufacturing process output wastes. The combination of these reductions increases net cash flow. In other words, CO2 technology helps to keep the production line moving with more productivity and lower operating cost. CPU-powered manufacturing processes generate cash flow by reducing or eliminating manufacturing wastes. CPU technology reduces both cash inflow and outflow before, during, and after a manufacturing process, thereby increasing net cash flow. Increased cash flows and minimized cash waste states directly impact the balance sheet, profitability, and sustainability of your business. An example of cash flow generation is the replacement of aqueous cleaning with dry CO2 spray cleaning. Aqueous cleaning employs multi-stage wash, rinse, and dry stations. These systems utilize a lot of space and they generate a lot of waste in the form of wastewater and labor. CO2 dry cleaning is a dry in, dry through, and dry out process which reduces time, space, labor, energy, and water. It also improves productivity of the process, cleanliness of parts, yield, and environmental quality improvements. Each CPU-powered cleaning cell generates over $1.5 million in cash flow each year,